Hi, in this video, we're going to take a look at DHCP for IPv4 operations and message format. And just a reminder, this is different than DHCP for IPv6, which we look at in other videos. Okay, first of all, what gets a static and what gets a dynamic address? Well, static address is needed on anything where we actually need to keep track of, or not keep track of, but know the address of. For example, the difference would be between a desktop computer and a server computer. A server computer, we need to know what the IP address is. So the desktop computer, your client computer, knows what the address is, so it can SSH into the server, it can ping it, it can access whatever applications are on that server or whatever it might be. So we don't want that address to change. We need it for perhaps name resolution for DNS. It's basically providing a service at all time, and we need to know what IP address that is so clients know how to access that service. Okay. So your router is also going to be a device that we need to manage. This is going to be important for things like routing protocols and things like that. And of course, your router is going to have multiple IP addresses on different, at least one for every interface. Same thing with switches. Your laptop is a client computer typically, so that doesn't matter what IP address it receives. IP phone, another client device. Your printer, in most cases, we need to have a static address on that so the client knows which address to send the print requests to. Access points and other kinds of servers are going to have static addresses. Your iTouch devices, so anything like an iPad or a tablet of any type, again, a client device. And anything like a refrigerator, yeah, believe it or not, there's actually smart refrigerators now. Okay. So when receiving an IP address information for IPv4, your device is going to receive an IPv4 address, subnet mask, usually the address of a DNS server, a default gateway, sometimes domain name, and using the IP config space/all, you can see all that information along with the address of the DHCP server. Okay. So your home router, here we have a little Linksys router, usually has a pre-configured range of IPv4 addresses that it's going to hand out. Your home router will act as a local DHCP server. So in this case here, it's going to hand out addresses starting with 192.168.1. So there's our private RFC 1918 address. It's going to this router here is also going to act as a NAT device, network address translation, because this is a private IPv4 address space. Okay, but the first address it's going to hand out is starting with 100. And it's going to give out by default 50 addresses. So that's 100 through 149. Why starting at 100? Okay, because everything prior to this is going to be for static devices, including our router, default gateway, printer, or anything else on our network. The client lease time for this device is the client lease time for this DHCP server when it hands out the addresses is going to default to 1 day. So the client will only be able to keep that address for 1 day before having to renew the address. And we see similar types of configurations on any type of server that's acting as a DHCP server. It has a scope of addresses, lease duration, and we'll talk about excluded addresses. Other excluded addresses we can add when we take a look at configuring it, at least the DHCP server on a Cisco router. Okay, so the message exchange starts off with the client sending out a DHCP discover message looking for a DHCP v4 server on the network. One or more DHCP servers will respond with a DHCP offer saying, I'm offering you this IP addressing information. The client will then choose usually the first offer it receives and says, I will accept this offer. And the server will then send back a DHCP acknowledgement saying, great, I have now allocated that specific IPv4 address to you. Okay. So here we can see this client has received an IPv4 address, subnet mask, a default gateway address, usually also a DNS server address, and a lease time. After the lease time expires, or prior to the lease time expiring, I should say, the client will send out a DHCP request requesting that it would like to renew its lease. And the server will typically acknowledge that. Now, I want to mention a big difference between DHCP for IPv4 and IPv6, and that's this default gateway address. Okay? In DHCP for IPv4, the server supplies, the DHCP server supplies the default gateway address. That is not the case in DHCP for IPv6. The only way that the device receives a default gateway address automatically in IPv6 is through the router advertisement message. We'll talk about that in a later video. Okay, so DHCP v4 messages are sent over UDP. So the client uses UDP source port 68, destination port 67. Server uses UDP source port 67 and destination port 68. Now, why is UDP used and not TCP? So remember, TCP has some overhead with it, right? We have the three-way handshake, and then they have to keep track, both sides keep track of window sizes, sequence numbers, what's been acknowledged, what hasn't been acknowledged, both on the sending and the receiving side. So there's quite a bit of overhead. Well, don't we want DHCP messages to be handled reliably? Well, yes, but we can do that actually a different way without the overhead of TCP. It's very simple. What happens with UDP is the client sends the DHCP discover message, and just like if you're asking for something, it's like you're at your favorite coffee house and you ask for a cappuccino and they don't hear you, and you just say it again. So if the offer isn't received back by the client just simply asks again. Okay, and so there's a number of times it will ask before giving up. And that's a lot less overhead and a lot faster than using TCP in this case. Okay, so here we can actually see where we have a single client, of course, sending out the discover message. And it's actually, we have two DHCP servers, and it's going to receive two offers. And it's going to usually accept the first offer it receives. So we'll accept this offer, the first one that it receives. Now it sends out a broadcast for the DHCP request saying, I'm going to request from this server, but it's a broadcast, so this server knows that it is not taking its offer. And this server knows that it is taking its offer. And then this side here will acknowledge the request. Lease time expires, renew the request, acknowledgement for the request. Okay. There's actually a danger, and we talk about this in other videos. We can do some things known as DHCP snooping on our switches and things, but there's a danger here that this could be a rogue DHCP device on our network, which could implement a man-in-the-middle attack. I won't go into this here. I talk about it in other videos, but it's why in your enterprise level, business level switches, you have things like DHCP snooping, port security, and other security measures on your LAN devices, your in this case, your LAN switches. Okay, So DHCP message format includes things like the client IP address, your IP address, server IP address, gateway IP address, and things like that. Let's take a look what that might look like. So here we have a DHCP discover message being sent by the client. Of course, it doesn't know its client IP address, doesn't have one, doesn't know a gateway IP address, doesn't have one yet, doesn't know the subnet mask, but it does know its MAC address. And that's what the server is going to use to bind with the IP address it allocates or assigns to the device, binds it to its MAC address. That's how it keeps track of who gets what IPv4 address. So here we see in the offer coming back from the server, it says here's your IP address, here's your subnet mask. Now, typically it will also include this gateway IP address, the default gateway address. So it uses this information both for the messages from the client and messages from the server, the information that is sent and received between both sides. Okay, so that does it for DHCP v4 operations.